In this video, I will show you how to condense logarithmic expressions such as these using a combination of properties of logarithms. Now, these are the properties I'm going to be using to condense the logarithms. We've got the product rule, the quotient rule, and the power rule, and also change of base, but mostly the first three. So, according to the product rule, if you have the sum of two logs, that's the same as the single log of the product. So addition can be condensed to multiplication. Similarly, for the quotient rule, if you have the difference of two logs, that can condense to the log of a quotient. So subtraction condenses to division. And then you have the power rule, which basically says if you have a coefficient in front of a log, you can move it up and it can become the exponent in condensed form. All right, a quick example before we get started. So if I have the log base 3 of A plus the log base 3 of B, according to the product rule, I can write this as the log base 3 of A times B. But to be clear, I can do this with more than two terms. If I have the log base 5 of P plus the log base 5 of Q plus the log base 5 of M, this can be condensed to a single log, the log base 5 of P times Q times M. Looking at problem number 1, first of all, understand that when you are dividing by 3, this is the same thing as multiplying by 1/3. So I would rather write this this 1/3 as a coefficient instead of a denominator like this. So this expression is the same thing as having log base 3 of W plus 1/3 log base 3 of U plus 1/3 log base 3 of V. So I have not changed anything so far. Now, before I can apply the product rule and condense this sum down to a single logarithm, notice how none of these logarithms have a coefficient in front. I've got to deal with that. And because on this problem, I do have these coefficients in front with the 1/3. So remember, the way I deal with coefficients in front is by using the power rule. If you have a coefficient in front, you can move it to the exponent. So quick example of that. Let's say if I have 5 times the log base 3 of M, that would be the same thing as log base 3 of M to the 5th power. So you can take this coefficient and move it to the exponent position. All right, and this is considered the condensed form. All right, so I'm going to do that in each one of these cases. I'm going to take this, this 1/3 and put it as the exponent. I'm going to take this 1/3 and put it as the exponent. So this would become the log base 3 of W plus the log base 3 of U to the 1/3 power plus the log base 3 of V to the 1/3 power. Now, another thing that we do when we go to condensed form is we remember that if I have, for example, n to the 1/3 power, that is the same thing as the cube root of n. Similarly, if I had n to the 1/4 power, that would be the same thing as the 4th root of n. And if I had n to the 1/2 power, that's the same thing as the square root of n. So for condensed form, you're always going to assume radical form. So instead of writing u to the 1/3 power and v to the 1/3 power, we will go ahead and put the cube root of u and the cube root of v. Okay, now we can use the product rule just like this. If I have log p plus log q plus log m, that's log p times q times m, single log. Now that the coefficients are out of the way, we can do that. So this is going to become log base 3 of w times the cube root of u times the cube root of v, a single log. Now, one small cosmetic change. When you have the same root and you're multiplying, you can put those together. Okay, for example, the fifth root of x times the fifth root of y is going to be the same thing as the fifth root of xy. Okay, if you have the same root, you can go ahead and multiply those together. So that's what we're going to do now, just to clean this up one more step. So this is going to equal log base 3 of w, and then we'll just put the cube root of u v. So this is the final answer. Okay, for problem number 2, I see that we've got this coefficient in the front, so we'll use the power rule to move that as the exponent. So that's going to wind up being out here. So, hey, 5 to the 3rd power is 125. So let's go ahead and do that as well. So that's going to give us log base 3 of 8 plus log base 3 of 11 plus log base 3 of 125. So now we can use the product rule, and this would be the same thing as log base 3 of 8 times 11 times 125. So let's just go ahead and figure out what that is using a 4-function calculator. So that turns out to be 11,000. So this is the final answer. So looking at number 3, again I see we have these coefficients in the front. So we will use the power rule to move those coefficients into the exponent position. So this 5 is going to come over here like that. So now I'm going to have log base 3 of x to the 10th power plus log base 3 of y to the 5th power. Now I can use the product rule to condense this down to a single log. So this will be log base 3 of x to the 10th power y to the 5th power. So that's it for problem number 3. All right, for problem number 4, again, whenever I see a fraction like this, I really want to look at this as a coefficient. So this is the same thing as log 6 log base 2 of 11 plus 1/2 log base 2 of 7. So now I'm going to use the power rule to move these exponents over. Okay, maybe I'll show it like this. So this 6 is going to come over, so this will be 11 to the 6th power. This 1/2 is going to come over, and this will become, 7 to the 1/2 power. But remember that the 1/2 power is the square root. So that's how we want to actually write it. So then I'm going to have log base 2 of, and I think we'll just go ahead and leave this as 11 to the 6th power, plus log base 2 of the square root of 7. So now we can go ahead and write the final answer. Using the product rule, this will condense down to the log base 2 of 11 to the 6th power times the square root of 7. So that's it for number 4. Number 5, we need to first deal with any coefficients in the front. So this will become u to the 18th power, and this will become v to the 6th power. All right, so now we are about to use the quotient rule. Subtraction condenses down to a single division logarithm. So this will be the same thing as log base 8 of u to the 18th power over v to the 6th power. And that's it. That's the final answer. For number 6, again, we will take care of the coefficients by moving them into the power position. Okay, so this will be the same thing as log base 2 of 12 to the 12th power minus log base 2 of 7 squared, which is 49. I'm not sure if we are going to leave it. All right, I think we'll just leave it for now. So now we will use the quotient rule. So this will be log base 2 of 12 to the 12th power over 7 squared. Let's start by dealing with these coefficients, which will become exponents because of the power rule. So that means we have log base 6 of a to the 12th power plus log base 6 of b to the 3rd power. Then we can use the product rule and condense this down to log base 6 of a to the 12th power b to the 3rd power. Let's move the coefficients to the exponent position. That's the power rule at work. So this is going to become y to the 4th power. So this is the same as log base 5 of x to the 24th power plus log base 5 of y to the 4th power. Now we can use the product rule and write this as a single log base 5 of x to the 24th power times y to the 4th power. Final answer. For number 9, again, when I see divided by 3, I understand that this is the same thing as having a coefficient of 1/3. So I'm going to look at this as log base 9 of c plus 1/3 log base 9 of a plus 1/3 log base 9 of b. So then I will deal with these coefficients. So this will become a to the 1/3 power, and this will become b to the 1/3 power, because that's the power rule. But remember that the 1/3 power is the same thing as the cube root. So what we have now is log base 9 of c plus log base 9 of a. I'm sorry, let's go ahead and write the cube root of a. plus log base 9 of the cube root of b. So now we can write the final answer, which would be log base 9 of c times the cube root of, and instead of writing cube root of a and then cube root of b again, let's just write the cube root of ab under single radical sign. All right, so this will be the final answer for number 9. All right, for number 10, again, start with your coefficients and use the power rule to move them into the exponent position. So now we have log base 5 of a to the 6th power minus log base 5 of b to the 6th power. Now the quotient rule kicks in, and we have log base 5 of a to the 6th power over b to the 6th power. And that will be the final answer for number 10. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.